Good morning. I'm good.
It's not morning over there, is it?
Nah, it's a rainy afternoon here in Norway.
We had a rainy day yesterday in Austin, Texas. Today it's
Oh,
just humid residue of the rain from yesterday. It's a rare occurrence that it rains here.
so
So
are you happy about the rain? Are you a
yeah, it's
gardener
nice.
or?
It definitely cools down the weather. We get like 105-degree days here.
Oh,
Pretty
it's still
wild.
that hot.
Yeah, yeah.
Okay, I'm just lifting up my
Not much
camera and
rain, I
trying
guess.
to build a nicer setup here.
Cool. So today on the Automate Construction podcast, we have Max from Rebartek, the CEO of Rebartek, a really cool company who's automating the building of rebar, prefabricated rebar units off-site that can be later assembled on-site, if I understand correctly.
That's right. Thanks for
I,
having
wa-
me.
I watched some of your YouTube videos to figure out what it is you're doing, and I understand that you started working in construction. You were working on a bridge project?
Yeah, so I'm a construction engineer by trade, and I've been working in industry for 15, 16 years. And the last project I've been working on as an employee was a big bridge project where basically the idea of Rebartek was born.
Sure.
Yeah.
And so in your previous construction experience, how much did you know about robotic arms and that kind of machinery?
Nothing. I thought that robotics was like rocket science. So as a construction engineer, I have had zero exposure to automation technology. And so for me, I thought it was in the same category. I had like, yeah, I have lots of weird ideas like building houses on Mars and building flying taxis and so on. And then basically doing stuff with robots was in the same category for me 3 years ago.
But from the get-go, you brought to the table a deep understanding of rebar and how you integrate rebar into concrete in the construction site.
Yeah, I mean, to a certain level. So I've been in the roles that I've had in the construction project. I was more like in a management role. So I'm not into like the deepest levels of structural engineering, but I have a basic understanding of it, and so I came into it more like through the problem statement. I saw from a project management point of view that we're spending lots of money on rebar, and that it was a huge pain in the ass for our project. And so there where I understood, okay, this is a huge problem. And then at the same time, I saw that we're using this method of prefabricating rebar cages in the project, but we were doing it manually. And then basically the idea was, okay, can't we automate this prefabrication process?
So how long from the initial point where you realized this on the site did you actually get to a robot that was tying rebar and placing the rebar on its own?
I would say until the first small scale prototype from working more seriously with that idea, it was probably half a year or something like that until
That's fast.
we welded the first rebars with a robot.
How, when you first built that model, did you start to build out your team, or were you working on your own?
Yeah, that's a because I think on my own I would have never started this, because like I felt like the automation technology was something like I
Daunting.
yeah I didn't have the balls to start working on that on my own. So one day there was an unemployed automation engineer standing in our site office where we were building the bridge, and was asking for if we had some work for him. And I was like, no, we don't have any work for you, but we are looking for interns right now. And so he started an internship with us, and then we started talking the idea, and then basically from there the ball started rolling. But then when it came to like founding the company, then that guy had been unemployed for like 2 years, and he was then 1 month before we founded the company, he was offered like a full-time employment at a different company. So he
Wow.
felt it was too risky to jump into like a startup from unemployment. So then I was there, okay, and he was like, no, I can't found this company together with you. And then I basically started funding it alone. Yeah.
but that gave you kind of the initial push forward to get going.
Yes, exactly. Without that guy, I would still sit in a shower and dream about this idea. But he was like, this is not a problem. Let's start working on it. And I was like, really? And then we actually started doing it. So that was quite cool.
And so now that you've come so far, I'm sure you have a much deeper understanding of the technology, and it seems less complicated at this point.
Yeah, I mean, I lost some respect for robotics, to be honest, and I'm trying to tell the people around me, and especially the people in construction, that in the end, it's like a moving mechanism. It's not more than that. It's like an arm that moves, and it moves exactly where you tell it to move. And so that's my high-level understanding of it. So I'm not the one that does the nitty-gritty detailed programming of it. And from a high-level point of view, it's that simple. But then everything that's difficult is in the details about it.
Sure. I guess the implementation from the engineering perspective, where it's all conceptual, onto the actual job site, where somebody needs to get the final pieces tied together. That's kind of the implementation where it becomes tricky and valuable.
Yeah, and from that, you asked me how long did it take to like the first have the robot weld and move something. I mean, then you're at a stage, okay, I can show something that works once, that's cool, and that's a nice video and everything like that. But to transform that into like a scalable, reliable machine that you can easily use and that works fast and reliably, that's where the difficulty is then hidden in the details.
Sure. So currently you're doing off-site prefab, and then you deliver the units you build to the construction site. But I saw you're building a gantry system with 2 robotic arms, and it almost seems like that's intended to go on-site or on other people's construction sites, so you can deliver the gantry system and they can buy that as a product.
Exactly. So that's our long-term ambition, is to have a mobile factory, basically, that you can set up relatively quickly on the construction site to make the rebar cages as close as possible to where you actually need them. But until that is like a certified and final product, it's going to be a while. So in the meantime, we have basically set up the same workings of that system, just in a simpler version in our factory here in Norway. And as you said, it's like, okay, it's stationary in our workshop right now, and we ship then the rebar cages to the customers for now. But long term, we want to ship the solution to the customers so that we can make the rebar cages on site.
Yeah, I wonder who your customers will be. Will they be construction companies that want to like vertically integrate their product offerings, or will it be independent businesses that want to set up an operation kind of like how you're doing right now, where you just manufacture the rebar and ship it out and only worry about that aspect?
So that's a good question, and we don't have the final answer on that yet, and we don't have to have it right now. Right now, we see that our customers fall into like 3 categories. One category is what you just described. I would call it a supplier. So that's company that are supplying rebars to contractors at the moment. And so some of these, they're already selling rebar cages as a product to their customers, but they make them in a very manual fashion. So that would be a possibility to just do that, to that they become our customers. A different solution or a different kind of customer are what you described is like the traditional contractors that are building something with concrete on a construction site. So they spend a lot of, and that's basically my background where I come from. They spend a lot of labor on it right now, and they can use a lot less labor and accelerate their project a lot with prefabrication. And then the third type of customer that we're actually working for quite a lot at the moment is precast plants. So they have a stationary factory where they are casting concrete elements in a factory, and then they ship their concrete elements out to construction sites. And so for them, it's also they also have a lot of rebar in that process, and they are quite manually. And so for them, it's also a good opportunity to work with our solution.
Yeah, how often are there repeating patterns in the rebar?
Yeah, that's a very good question, and that basically boils down to the essence of Rebartek. Actually, is like there is the odd rebar thing that we call it. We're talking about cages and cage types. That is that you have in series. How often do you build the exact same cage? And there are certain projects, for example, in tunnel projects, where you build like 10,000 times or 100,000 times the same cage. But that is really the odd outlier. So like of all the projects that are being built, right now, what we see with the customers that we have, 85% of the cages that we're delivering are like one-offs. So we deliver the same cage once or twice, and only 15% of the cages that we have delivered are more than once. Right now, we have made one cage 6 times. That's our record right now for the niche that we are in.
Do you think that has to do with the current like design environment for rebar, and engineers just kind of like design the rebar however they see fit and make it strong enough? Like,
Yeah,
is there lacking a certain communication where everyone could use a similar design?
Yes, absolutely. So like for what we see from the customers and the projects that we've been working for so far, there is there's different models like how to arrange a contract and a project, but often it's that you have a customer, a client, that's one entity. Then you have like a designer, an engineer, or that consultant that makes the structural design, and then they prepare a bill of quantities or something like that, and some drawings. And then you have a third entity that is the contractor that has to build it, and then you have a fourth entity, which is the supplier that supplies the rebar. And suddenly you have like 4 different parties working in different directions with different incentives, and it's difficult to arrange for a fully optimized process in this. So definitely one of the challenges is that most often when somebody designs some rebar today, they're not spending too much thought on like how to build this in a very effective way, and almost nobody thinking how to build that in an automated way. And that's why part of our solution is to provide a structural design software or plugin for that basically shows our customer, okay, here's what we have ready in our catalog. If you adjust our cage type that we have ready for you and adjust it and customize it towards your project, then you can press play and just make it automatically with our machine. So, but for that, you have to think about that already in the design phase. So if someone just designs the rebar as usual and not thinking so much about how to build it, then you have a hard time building it in an efficient way afterwards.
Yeah, you make it clear in your logo that you're a software company as well. I didn't notice until I guess I watched one of the videos and it kind of blew up that the slash is a piece of rebar in the middle.
That's the idea, yeah.
Yeah, it's clever.
Thanks.
So the machine learning aspect, how is that going to be? Is that to figure out the best design methods, or where does that live?
So right now it lives mostly in the quality control. So one thing that a lot of clients are quite skeptical to welding rebars, because you must not weaken the structural strengths of the rebar. In Norway, for example, there was an oil platform that collapsed and sunk because the rebar wasn't done properly. So the rebar has a very important purpose in the whole structure. And if you do the welding in a bad way, then the rebar doesn't have the strength it's supposed to have. So you really have to make sure and prove to the customers that the welding has been done in a professional way. And so for that, we have a system that basically does the quality inspection in an automated way. And then in long term, the ambition is also to, right now we're building quite a big data set of the projects that we're doing. And then the ambition is that also to make our design software smarter based on the projects that we have done and optimized. What we're seeing also in the design is that quite often the structural engineers, they're not getting paid for making a highly optimized design. So you rather put a little bit of extra rebar in it to be on the safe side. But what we see is that you can actually save quite a lot of the material by optimizing the design. And here's another cool thing that basically some of the projects that we're working for is like, for example, in a bridge project, they're using quite advanced software already to make the structural design of a bridge, for example. So they're using like parametric design and modeling and Grasshopper and so on to make a really cool design. And then they're quite frustrated because they have to dump down the design again so that it becomes something that you can put in a drawing that a human can understand and build. And so typically, if you look at rebar today, it's like in a constant pattern. Every 15 centimeter or so, you have a rebar in straight lines and so on, because that makes it understandable for a human, and you enable a human to build it. But actually, a robot, you can feed a much more complex design directly to the robot that you would have a hard time explaining to a human. Mm-hmm. So by that, we enable a more structurally optimized design. And then the other thing is also what I've seen on your podcast is that there's a lot of 3D printing startups and also universities, and rebar is still quite a big problem in that process. How to optimize that and how to find a printing process that can incorporate structurally reinforced concrete also. So that's definitely in the next step also an interesting application for us, where we're in the talks with some startups, 3D printers, to see a possible collaboration on can we combine an automated rebar process with an automated printing process and make even more complex designs than in the end.
Yeah, both technologies are so fresh and so new, but even if it's not 6 months from now or not a year from now, I'm sure they'll integrate eventually because they're chasing the same goal of automating construction. And yes. So like down the line, we're
basically approaching it like from two different angles, but I agree with you that there hopefully is a merger somewhere in the future. So while we are, our first step is more towards a traditional concrete casting process and providing the rebar for that, and then more and more increasing the advancement and the level of complexity in our geometry. It's the other way around, basically, for the 3D printing startups. They're starting with really complex geometries and trying to print that, and then slowly working into a more industrial approach so that it can scale more and be applicable to more applications.
Mm-hmm. So now, how big has your team grown to?
That's always a good question, and I lose count sometimes. But I think we are 7 people full-time, and then a couple of people part-time. And then we also have some interns working for us, and also like some students that are doing student projects together with us.
Are you guys currently staffed up, or are there positions you're still looking for?
I mean, I'm looking for a lot of people, but right now I don't have any money to hire more people. So first, what we have to do now is we have to basically, get a little more funding into the company before we can hire more people.
So right now, as the CEO, your primary focus is to get more funding.
Yes. So there's two. One is basically to increase the pilot production that we have, both like in serving more customers and serving it in a more productive way. And then the other is we see a bottleneck. Some customers, they want too big things from us or too much, which we can't do at the moment. So we need a bigger workshop and more equipment to be able to serve to be able to serve more of them. And for that, it's like a little bit like of a cat that bites itself in the tail. Like the investors want to see more revenue and more sales and so on, but for that I need more money, and then I'm like, okay, well, we're trying to make that work out.
Yeah, if you get it really lined up perfectly, maybe you get a purchase order or something in advance.
Yeah, that's definitely one way that we're trying to bootstrap ourselves right now, is to make more of our production and to make more profit out of it. But we see that we could grow faster and say yes to more customers if we also have a little more of investor capital to operate with.
Yeah, it makes a lot of sense. And especially since there's projects, like you said, sometimes there's 100,000 of like the same repeatable unit. If you just got one deal like that, you could be busy for a year.
Yeah. Actually, we would be busy for like 2 years. But the thing is that this kind of project is like a really huge project, like several hundred millions of dollars. And the rebar is like a critical component in that project. So before they let us, like a little startup like us in there, you first need to show like a track record that you are a reliable provider, because in the end, if they choose you and they trust you to deliver like rebar cages, a huge project could stop up, and it could like cause a lot of damage if you're not able to deliver. So that's why we are working like for smaller customers to build up a reputation and like a track record, so that hopefully we gain the trust of some bigger customers soon.
Do you have any estimates on the cost savings? You're in Norway, so I guess it would be localized comparisons, but
yeah. So the nice thing with Norway, right? Yeah, I can't tell you the exact numbers. One thing that I can tell you is that in Norway it's quite nice, because the labor costs here is very high in Norway. We have approximately our contractors calculating with like $40 to $60 per hour that they're paying for a worker. Mm-hmm. So that makes it very attractive to make it more productive, the rebar process. Right now I can't go out publicly like what our exact savings numbers are at the moment.
That's okay.
Yeah.
That's pretty common. A lot of the companies I talk to, there's always like, that's like inherent in startups.
Yeah. And it's, in one way, I think sometimes it's a little sad that it is like that, because as a person, I think it's, we enable much more collaboration and advancements if we can be open about things. So when I then want to talk to, for example, 3D printing startups, okay, how fast is that? How expensive is that? And so on. Then it's like, okay, we can't talk about this and so on. And in a way, I think for myself that I cannot like communicate that numbers publicly like that is also like a sign of weakness in a way. Like so. Let's see, if we talk in a year, maybe I can be a little more offensive and. Yeah.
I don't think you should worry about it. I think it's so typical that like people in my position are so used to it that like it's fine if there's things that can't be discussed, it just gloss over or whatever. So what's going forward? What projects are you excited to start in the future?
So basically, we have been into a couple of them, looking at the different categories that our customers are in. One is this mass customization, so where we basically get better and better of making one-offs in a more and more automated way. So that's really cool, and I think that's one of our biggest differentiators at the moment, is that we really want to enable this one-off production in a very efficient way. At the same time, we talked about this big project when they make like 70,000 of the same cages. So that would be really cool to land for us, because then you're talking about like $24 million or something like that of rebar in a single project. So we hope to land something like that maybe in the end of this year, but hopefully during next year. I hope to see one of our robots in a project like that, working almost 24/7, just pumping out the same thing. And then the other thing that a little more long-term excitement, it's a little too soon for us right now, is this collaboration with 3D printing and finding an integrated process that does both the rebar and the 3D printing. Basically, we don't want to solve the 3D printing once more, but we are basically looking for a partner that has solved the 3D printing of concrete, and hopefully together we can find a process to combine the rebar with the 3D printing.
Yeah, especially with the gantry looking system that you have, it seems like you could just take the arm and replace it with the printing head and have the same robot use the same tech.
Yeah, I mean that's one of the visions I have. I'm not working so much with that right now, but what I see is that if I see at the different construction robotic startups, is that everybody of us builds more or less the same hardware, more or less from the bottom up. And that's just wasteful in my opinion. So if you look at software development, it has become very easy and cheap because there are so good platforms to build on, and you don't need to reinvent the wheel. You have like really good, you don't need to work on the low level stuff that's just ready for you, and you can just build the functionality you need. And I hope that we will get there in construction robotics also in a while, that we just have common hardware platforms, and then we have like this robotic cell out on a construction project that can build stuff, and basically the application that you run on it, if you like 3D print concrete or make rebar or do something in wood, that's something you change the end effector on the robot and you change the software, and then you're ready to roll. And then we don't need to. There's a lot of things that I think could be a shared platform in the future.
So, as far as software goes, the software you're developing is mostly to operate the robot?
Yeah, it's. I think in general, I would say three things. So it all starts with the design, basically. So we are integrating towards structural design software like Tekla and Revit, where basically already at that stage you have to make sure that you make a design that the robot can build. And then, as you said, from there you have an automated connection that feeds basically that information from the structural design software directly into the robotic production process. That's the second part of the software that focuses more or less on the hardware and the production process. And then the third aspect of the software is like I would call it like project management software or something like that, to like have a dashboard and monitor how the production process is going, to let the customer see where their order is and when it will be delivered, and see their invoices and integrate all that into like one nice package.
Does your machine bend concrete?
We're not bending. Yeah, so basically that is like standard machines that you can buy off in the market. So there's quite advanced rebar bending machines. So we don't want to reinvent that. It's a relatively expensive and big machine, so we don't have that in our workshop right now. So we're buying bent rebars from somebody that has the machine. But in the end, if you look on YouTube, you will find some videos that other people have integrated basically a robot to that machine that picks the rebars from the machine and places it. So that process is more or less solved. We haven't integrated it into our solution yet.
So your concentration is tying the rebar cages?
We have done some tying of rebar cages. Right now, the customers that we're working for here locally, they prefer welded rebar cages. So we're doing a lot of welding. And yeah, then basically you need to enable this one-off process so that you can quickly change the design and change the machine to be able to make the next cage that is different from the cage you just made.
Which do you prefer, welding or tying?
Well, they both have their advantages and disadvantages. From a robotic point of view, welding is slightly more difficult to achieve. It's there's a lot of parameters you have to hit the right in the right way, and you have to be very precise on where you weld. If you are like 2-3 millimeters off in the wrong direction, you don't get a good weld. While with tying, you have a little bit more robustness because if you're like 2-3 millimeters off in one direction with the tying, that's something the tying mechanism can compensate for, and you still get a nice tie of the bars. The advantage with welding is that you get a much stiffer connection. So if you transport the cage, lift it with a crane, put it into the formwork, you get a really nice stiff cage if you have all the connections welded. With the tying, it's a little more like it's hard to get the connection as stiff and tight. So if you transport it by truck and so on, then some rebars might be out of place, and it's like
it seems to me it would be impossible to get it as stiff because the rebar, it's just tied with a wire, so there's always going to be a little wiggle. even if it's like a tiny amount.
Certain customers and legislation and rules that don't allow welding because of the quality aspect that we have talked before, but also
you mentioned
because
an oil rig failed from welded.
No, it didn't fail from welding. It failed because the rebars were not placed enough and accurate enough.
But they just happened to be welded.
I'm not sure if the rebars in that project were welded. I just know that in the reconstruction of the project, they found out that the rebars were the reason why the structure failed.
It sounds like you're explaining that people have some kind of fear of the welded system, and
Yes.
a lot of people don't trust it. But from what you're saying, it sounds like it's more promising, potentially.
Well, as I said, it's like it really depends on the case and what you want to do. So, for example, some of the bars, even though we weld most of the cage, some of the bars we tie to allow an adjustment. So some bars have to be placed extremely precisely, and then we say, okay, we just put it there and loosely. We put on 2 ties, and then you adjust the position of the bar in the final formwork, for example. Another thing that is a difference between welding and tying is that in regards to if you have dynamic loads. So for example, you have regions that have earthquakes, so seismic activity, or if you have a structure that is swinging a lot, for example, a bridge, then some customers say, okay, you can't weld it because they want
to have the movement so it can absorb the
I forgot the fatigue, I think is the English word for it. So if you bend steel a lot of times, at some point it starts cracking, and by welding the material, you're changing the properties of the steel, and so it gets less flexible and
more brittle.
Yes, more brittle, and it's more suspect it can easily it cannot take as much repeated load changes. So then there are some regulations. For example, the Japanese customers that we're talking to, they are very no, we can't weld here. You have to tie for us.
But in Norway, there's no earthquakes, right?
Not that I'm aware of. Maybe there is some, but in generally not. And I haven't done too much research into the exact science of like the steel science, like how much welding energy you need before it becomes brittle, and how much load changes you need before it becomes a real problem. But right now it feels like there's some binary fear, as you said. It's like, okay, because it might be a problem, we don't want you to weld at all, and then we say, okay, then we just have to tie it if that's what you want.
Yeah, you guys have done so many, probably the most automated rebar of anyone maybe. And so now you know the limitations of what's easy to do with the robot, what's easy to tie, and what forms. Are there forms that are more difficult for the robot?
Yeah, absolutely. That's a very interesting learning curve to play around with. And that's why it's so important for us to do like real projects for real customers, because we think something in our research lab here, and we build something, and then when the cage gets out to the customer and has to go into the formwork, then you like, oh shit, that doesn't fit, and this we have to fix. So there's a lot of painful learning involved, definitely.
So now that you know the parts that are difficult and the parts that are simple, might you be able to come up with some kind of easy form to build that could be repeated and say, hey, listen, if you could implement this piece in your design instead of just coming up with whatever you want, then we could provide the product cheaper and faster.
Yeah, that's exactly the idea of our design software, basically to give the client a tool to see, hey, these are the proven solutions. They're easy for us to make. Please work with that, because then you can just play and the robot can make it for you. That's exactly what we want to do.
It's unique because it disrupts the traditional construction schedule of first doing design, because now you need your rebar supplier involved in the design process from the get-go.
Yeah, it's it's kind of not many people work like that so far. So there is, I think it's a really growing trend to see in the industry. Like design for manufacturing is like a big buzzword that is going on right now, and we see more vertically integrated providers that are also like more going away from like building one-offs to more like having a catalog of products that they offer to their customers and more standardized. So for them, it's much easier to work in that way. And for us, it's more difficult to like when we work for a contractor and they receive a design, they cannot go back to their designer and say, hey, you should have thought about that before you made this design for me. So there's quite a lot of it's not easy for a little small startup to like change the way the industry works, but we can go out and say, hey, please do that. Then we can make it cheaper for you. Then we can make it faster for you. And there's quite a lot of interest from big construction companies that want to see, okay, how can we do it? They want to test it out. And so I'm in one way, I'm frustrated because I know like our solution is not going to change the industry as a whole, and it's not going to give the big productivity gain. Of course, we make one process more better, but like in the whole, we need other things to change to be able to achieve the really big gains in our industry. And that's, I think, what I see is what makes me a little more hopeful about the future, is that I see more and more of that happening, that more and more people come to the same conclusion and start working on solutions. And okay, I use this car analogy. Like if you had a friend that is good at drawing cars, you know, and he would draw a new car for you, and then you would go to BMW or Chrysler and say, hey, can you build this car for me? What do you think, what would the price of that car be? You know, it's like, it would be a very expensive handmade one-off car. Mm-hmm. But that's exactly what we're doing in construction. We have like somebody that needs a new house. He goes to somebody that draws a house for him, and then he asks somebody else if they can build the house for him. And then, and then this is like a teamwork thing. You have like, I don't know how many companies and people working together in a project. And once you have figured out how to work together, and like after 1 or 2 years, you know how to work together, how to build this project, you have a football team that works and that wins games, you know, and then you say, you know, right now that we've figured out how it goes, let's finish here and start from scratch. That's what we're doing in our industry. It's like, what the heck is going on? Nobody, like once you have figured out how to work together, you stop working together and start from scratch. It's like,
yeah, it is really complicated. There's always so many players, even just to build one small house. It's very, very rarely one company. It's almost always subcontractors. And then you also have to get the electric utility to plug it in. Like there's 10 to 12 to maybe even more different players involved. And like you said, they finish the project and they all go their separate ways and find 12 more people to work with on the next one. And
any team game, soccer or football or basketball, and like each game you would play with a new team. Like how many games do you win like that? It's like,
yeah, that's just an inherent problem of construction, the biggest industry in the world. It's going to be, I don't know if that one's solvable.
I think it's solvable, and I see more people working on solutions. So that's really good in my opinion. And it makes me very, I'm looking forward to all the stuff that's happening in the next couple of years. And automating something with robotics is like a small part of the solution. It's not the end all to making the whole industry more productive. There's some bigger things higher up in the value chain that we have to solve together.
Yeah, it's interesting how you say like that, bigger things in the value chain, because when I look at the construction innovation historically, none of it is big scale. It's all small scale. Like it's mostly in handheld power tools that are just like slightly adapting the way that something is done traditionally.
Yeah.
And all these handheld power tools, like they change slightly, but they're still just after the same goal. And now people are thinking bigger scale.
You make me think of two funny stories. One is that here in Norway, we are talking about digital construction, and we are very proud of that. We have some projects that are like drawing-less, they're completely built just with a BIM model, and then you end up having a worker that holds an iPad in his hand to look at the model, or he has some VR glasses on and so on. And then in the other hand, he has the same hammer that he's always had there for the last 60 years, like, or maybe a power tool, like you said. So that's somehow where digitalization ends at the physical stage, and that's cool. Where the automatic more building processes come in and combining that, hooking it up to the design process. The other thing that I thought of when you said like historical development in construction is. There's a German construction engineer. He was active during the time of the Second World War. His name is Konrad Zuse in German. He went to the same university as I did in Berlin. And actually, he's one of the inventors of the computer. So while Alan Turing is quite famous for the inventor of the computer, if you look at it, there's probably like 5 or 6 different people that are the inventor of the computer, because they all find like a different way of defining what's a computer. Mm-hmm. But that guy is a construction engineer, and he was so fed up with all the calculations that he had to do that he invented a computer to help him make the calculations. So, and I think that's pretty cool. Like construction engineers, they come up with creative ways how to solve problems. And if I look out on bridge projects and so on, we have pretty big, impressive machinery out there to build huge things. So, and that, as an engineer, I get fascinated by it. Like, there's a lot more cool things to build to make it even better.
Certainly. Some people think that innovation is like the internet was one of the big things that changed things, and then computer coding and that stuff. A lot of people think a lot of the innovation is behind us. But there's so much left to be innovated with all of the tools that we have right now. And it's a lot of things that have been developed separately. And it's I mean, kind of like you said, when you said like you lost respect for robotics a little bit, it's not like, it's just that it's all available now. So it's less of a mystery, and it's just integrating things that haven't been integrated before.
I 100% agree with you. It's like it's becoming more affordable. It's becoming easier to program. So we'll see lots of really, really cool innovation. Like VR glasses, they cost like a couple of $100s now. And Elon Musk has his implant directly into the brain, and it's like, man, there's so much cool stuff happening ahead of us. So that makes me really excited. And also, like we are like, we're going to be pioneers. That we're colonizing a new planet in this decade or the next one. Think of all the stuff that has to be built on Mars and has to be developed there. It's like we're in the middle of it. It's like unbelievably cool.
Yeah, I think for Mars, I don't think they're going to build on the land, and I don't think it's going to look like regular construction. I think what they're going to do is use the Boring Company machine and dig down underground, because the big problem
in the start, when I look at the crazy rocket factory that Elon Musk is building, he's probably just the first 100 rockets, you can just live inside the rocket. You don't need to build a crazy house around it so that's probably going to be the cheapest and easiest way in the start. But then if you want to have like 1 million people or so living up there, they can't be all living in rockets. That's going to be boring. So I don't know if they're going to build tunnels or build domes or
I think they need to do tunnels because of the radiation. So if you don't have tunnels, it's going to be really difficult for them to protect from the really high levels of radiation on Mars. If they go underground, then they're going to be safe from it.
Yeah, it's going to be exciting. I'm not too keen on like living in a tunnel on Mars in the next decade, but the cool thing is, like with our mobile factory, a lot of stuff can be like operated and done remotely. It's and then just coming back to Earth, there's so much things on Earth that we have to fix that are really messed up right now with the way we live on Earth. So like the sea levels are going to rise, I don't know how much. So just that is going to be like a crazy engineering challenge where we have to, like, a lot of cities are going to drown if we not build stuff to rescue them. Then we need like green power that we need to make, and we need to build a lot of stuff for that. I don't know. There's so many cool things we have to do.
Yeah, it's definitely an exciting time. Has the coronavirus affected people's perception of the automation work you're doing?
Yeah, I think so. For us, it's a little, or for me personally, it's slightly odd because we have been affected in March and April here in Norway. So there were schools were closed and stuff like that. But in the end, Norway got out in a good way out of the Corona crisis. So actually, right now, if I think there's a measurement, it's called like the increased death or something like that. So you statistically, how many more people have died this month to compared to a normal month? And actually, in Norway, that number is negative. So less people are dying than statistically would die in this month.
Because less people are driving and whatnot.
Yeah, because like there's less people dying of the flu and stuff.
Less people going out and drinking and stuff.
Washing your hands and kissing other people and you're not checking hands anymore. That's quite weird actually, because in that way, in a lot of ways, our daily life is quite normal here. Like nobody is wearing masks and people are going to school and stuff like that, and businesses are open. And then in a lot of ways, we are quite affected. Like tourism is a big industry here, and there's hardly any tourists coming anymore. People are buying less fish from Norway. The oil price is low, so it is definitely we are affected as well. So it's like slightly in one way it seems kind of normal compared to what I see in the media from other countries, and then in a lot of ways we are also affected. And so for me, when I think, okay, how is coronavirus affecting the business and so on? Now, there's two questions or answers to me. There's the technical aspect of it, where I think like having less workers on the construction side and having more degree of automation and so on definitely helps in this way. And another way, I think, not really coronavirus, but we have this. I think we are on. It might be that we are on the start of an economic downturn. And construction industry is then slightly behind the curve. So what we see a couple of long-term indicators here for the construction industry in Norway, while everybody's working still at full speed, there's less new housing projects being started. So if that trend is going to continue for another couple of months, then some contractors, they will run out of work. So then, and I don't know, I think the virus is just the last drop on that. We have had like economic growth for 10 years straight, which is kind of unusual. And now the downturn, many people are thinking, okay, we will have an episode of downturn here. Let's see how long and deep it will be.
Yeah, we'll see about that. It'll be interesting. But yeah, I kind of meant on a more micro scale, kind of how the automation has less people on the job site and maybe less people in contact. With rebar, people are usually like pretty close together. One person's holding it, maybe one person's tying it or something.
Yeah, it's a very labor intensive task. So you have like in one of our customers' factories, you have like 30 people working there putting rebars in, day out. So
but
if you
for Norway, people aren't really wearing masks right now, and it's not too. People shaking hands or no?
One of our customers, he did it for a while. They split their operations into a 2-shift operation. So if one team would get sick or somebody in one team, they wouldn't have to close down the whole factory, but just one team.
That's smart.
But they closed, they went down to normal operations now. So they're all working together in the same factory. Before it was also, people had to have like different lunch rooms or like less people of lunch in the room. It's like they're working together again and they're sitting in the same lunchroom. There's like limitations. You can only have a party with like 20 people and stuff like that. But you have to be more careful. You have to wash your hands, and then you have to adhere to certain rules. But overall, to me, it feels pretty normal in a lot of ways.
That's good.
Yeah, we are really lucky. I mean, people here in Norway, they trust their government. And Norwegians, it's pretty amazing. Trust is like a big thing here in Norway. So like, there's a lot of people that still don't lock their houses, where basically the house door of people just is unlocked because you trust each other.
Mm-hmm. Do people own guns there?
Yeah, I mean, hunting is quite a big thing here. So you need to have like a hunting license and you need to have a gun license. So, but apart from that, it's not such a big thing as in. I don't actually know the numbers of gun ownership in Norway, to be honest.
What kind of hunting is there in Norway?
Well, so I grew up in the city in Germany, so I don't know the nitty gritty details
Right.
of that. But elk and moose is basically the biggest thing walking around here. So that's a very popular thing to hunt in fall, and people are like a lot of people are quite religious on that. They like save their vacation for it. In the fall, there's like a week of where they go hunting together, and then there's all the other animals that are living in the woods here. I don't know what the some people go for birds in the mountains, and then other people go for the deer and so on in the woods.
Your accent sounds more like Norway than German to me.
Okay, yeah,
Are you German?
I've been living here for quite a while.
But you were born in Germany.
Yeah, I was born actually quite funny in East Berlin. So I when I was 5, the wall fell. So I got a little bit like of like socialism and communism and so on in my blood and in my family. And then when I was 5, then it became one Germany. And now I'm the lucky guy that can enjoy all the freedoms of traveling around in the world. And yeah, not right now, but like in a normal day, I there's quite a lot of freedom for us.
That's a big event when you were 5. When I was 5, 9/11 happened.
Yeah, yeah.
It's
That's
weird
also
seeing something like that from such a young age because you, in the moment, you don't really understand the significance.
no, that's true. I still remember the moment though. You probably also remember 9/11, I guess.
So that was symbolic of like unity, and I guess that was a very happy time for Germany.
Yeah, I think in a lot of ways, at least from my perspective, of course, there were like some people that were quite sad about like the socialistic experiment failing. They were quite invested in this idea, and I'm this person. I can say that some things are good and some things are bad. For example, if I look at China, I can say, okay, there's some things that China is actually quite impressive with, and then there's other things that China is horrible with. And that's something I can say about the US, about Europe, about Germany, about Eastern Germany. So there were certain things that were good that they did in a good way. And of course, there were a lot of things that were bad also.
Yeah, I mean, engineering from Germany is always pretty incredible.
Yeah.
Are you a cars guy?
To be honest, not. I grew up like in a city with a bicycle, so for me, a car is mostly a money drain.
So where did your interest for like tech and robotics originate, or just from the need of for rebar?
I don't know. I remember being a small child. I was very impressed like with like big giant machinery, like looking at construction site. That's something that like I still I get big eyes when I go out on construction site and see all the huge equipment.
Sure.
That's then for a while I thought, okay, in the military they have a lot of cool equipment. But then I thought, okay, if somebody has to tell me whom I have to kill, and it's some weird politician that then I figured out that's nothing for me. So yeah, I ended up in construction.
Yeah. And did you go to university? You
Yeah,
did.
yeah.
And civil engineering or
Yeah, actually, the first kind of studies I took, it was a bachelor studies. I don't know what the English translation for it is. Maybe like something like called industrial engineering or something like that. So it was like 60% technical stuff about construction engineering, and then 40% was like management, economics, law, to give like a thing of both. And actually, at the same time, I was an apprentice in a company. So I was like half a year in school and half a year an apprentice in a company, and that was really spot on for me to have like a really practical approach to to construction.
interesting. That's almost similar to my major, which is like business and engineering. So it's like I would say 50% of the engineering stuff and like physics and that kind of stuff, and then 50% the business side. So it's a
Hmm.
little less focused on construction, but yours is like the construction version, I guess.
Yeah, yeah. So my technical part was about construction, so physics, engineering, structural engineering, and so on. And the other side was more like the management or so of construction.
Cool.
Yeah.
what do you think beyond concrete and rebar? What's another thing that could be potentially automated and work synergistically with your technology?
I think the general principle of integrating design with production into design with automated production can be applied to a lot of materials and methods, and I think we'll see more and more of that because both the software and the hardware becomes cheaper and easier to master. So yeah, you can see it for steel, for wood, for concrete. I think that we'll see a lot more of that.
Yeah, one day when I have a deeper understanding, I guess I would like to make a video about how to design a building for maximized automation so that people in the design process can tailor their decisions to kind of getting the most.
You should look into certain companies that are doing that already. Basically, they have a catalog of different structures like factories, buildings, office buildings, or so on that they have in their catalog. And then you as a customer, you can, like a little bit like cars, you can choose the color and you can choose the Model X and the Model Y, and you can choose what kind of seats you want to have. And then, and then they have, once you have chosen that, they have everything else ready, basically. Then they press play and then they start building it.
Yeah, prefab and those like really modular construction methods are super popular in your region. And to my understanding, that's mostly because it gets so cold that you need to build very fast on site, because you can only. I
mean, my perception when I drive around here and see how people are building houses, for example, like single houses, I'm shocked that it's like a very manual, traditional process of like all the separate timber bars get put down together manually on site. So I don't see that high degree of in my personal view. So I don't know the big numbers overall of that, but I think it will be a growing trend. Coming back to, like, for example, my East German roots. It was more common to have like mass fabricating the same house, like after the Second World War in a lot of Eastern Europe. There was big destruction after the war, so they needed to build houses fast, and they developed industrial processes to build the same house from a catalog really fast. But somehow that stopped. It was not the most sexy houses, and you can like hear your neighbor fart in their apartment because like there's bad sound insulation and so on. But I believe that with a more modern approach and a more higher quality of things, we can go in a similar direction. You can have a different facade and different color windows and so on. So you will not necessarily see that the house has the same standard modular build-up that it has.
Mm-hmm. When you weld rebar, what's the filament material that you use? Or are you just welding the two steel pieces together?
There's different welding methods. So one is more the traditional, what you were just talking about. It's called MIG or MAC welding, where you have a protective gas and you have a filler. To be honest, I don't know the exact metal composition, but we're using like some standard filler. And then there's another method that it's called resistance welding, where you just use force to push the bars together and a lot of current to weld them together, but you don't have any additional material or gas that you're feeding.
Okay. And you don't use that method, or you do?
We are working on that method. So right now the technology that we have implemented is MIG welding, because it's a little less capital intensive. But if you look at other rebar machinery that is out there today, a lot of them, they're using the resistance welding technology. But it's like, or for example, also the ETH project that you mentioned, Meshmold, they're also using a resistance welding technology there. So it has advantages, but we don't know too much about it yet. We are on our starting journey with resistance welding.
Cool. It's pretty incredible. You guys are, how old is the company? It launched like 2.5 years ago?
Yeah, so like in 2018, when I met the guy in the bridge project, I started working part-time on it. So in spring 2018. And basically, I continued working as an employee 80% until the end of 2018. So since 2019, I'm working full-time on Rebartek.
Cool. So you mentioned you guys are trying to raise money. Do you have like a current goal for how much you're trying to raise this round?
Yeah, we do. And I think that's one of the topics where we, again, don't go into all the details publicly. That's something we want to discuss in private with the investors.
And is there any call to action that you would like to give to viewers, like something you'd like them to take a look at, or?
Yeah, I mean, depending on who the viewers are, like one call to action that is for me important is like for young construction engineers that are maybe just finishing their studies or that are fresh in the field. I can really encourage everybody to learn the basics of programming, because I think that's the language, at least the logic. Engineers, we are pretty good already at understanding logic. So programming is just another language to express the logic. And it's getting so easy so find yourself a nice project to work on and learn yourself some basic programming skills in Python or something like that. Because amongst the blind, the one-eyed is king. So you don't need to be any professional programmer. If you know a little bit of programmer, you are really the king. So like you're going to start working in some company, in some project, and like even if you know a little bit of Excel, you're sticking out. And if you know a little bit of programming, you can solve a lot of problems in a nice automated way. So that I think is a really cool way to start diving into any way of automation, be it software, be it design, be it doing something with hardware and robotics. The really foundation is like logic and programming. That's an extremely valuable skill that you can have. And what we have seen again and again with students, for example, that are working for us, they work with us for half a year. They come to us and they're a little scared. Can I work with you even though I don't know any programming? I said, yes, of course. The only thing you need to know is that I need from you is that you want to learn it. So if you want that, most of them, they end up, okay, then they can program something, they build something cool, and they're really happy.
What kind of programming language is the most valuable for them to learn, do you think?
That now you get, again, I'm not a good professional programmer, but
for Rebartek, what's the most valuable language?
Something that's very popular at the moment and that a lot of people are working with is Python. So there's a lot of libraries, a lot of machine learning, robotics, and so on that you can do with Python. And it's also very accessible. It's relatively easy to learn. There's a lot of material out there, so it's probably a good start point to start with.
Cool. What about if they want to learn more specifically about Rebartek?
I mean, we are open for interns. We are open for employees.
But like, what about customers or something, or just people who want more information about the work you're doing? Is there like, where do you share information about that kind of stuff?
So we haven't been too good like about updating our webpage. I don't know, you might have noticed it. I'm trying to put some stuff out on LinkedIn. And then, I mean, if someone is very curious, just send us a mail. We are quite open about just, reach out on LinkedIn or mail or so, and then we can pick it up from there. Right now, we are actually a little, we have a quite local focus right now. So we're making cages for local customers here in Norway because it doesn't make sense to ship a cage very far. And then what we're looking for to do next year is that we want to find some customers probably in Europe or maybe the Middle East to like test our robot at their location. But like what we figured out, it's like a little too early for us to like ship our robot to Japan or to the US. We are not there yet quite technology development.
I wonder, like the Middle East, I'm sure you've heard about, they say they want 30% of new construction to be 3D printed by 2025 or 25% by 2030, whatever it is. Yeah. I wonder if they would consider your technology 3D printed, because it is being assembled. It's being assembled by a machine. The only difference is it's not a continuous line of like a wet filament that's drying. I mean, it does achieve, it seems like their goal in 3D printing is they have a similar construction labor shortage that you have in Norway, and they have a lot of demand for buildings. They want to build stuff and they want to not need as many people that they have to pay on the work site, because those people aren't even available to work. And they're making this big initiative towards 3D printing, but clearly their goal is automation. I don't know why they would specifically go after 3D printing, or I don't know. Have you got any interest from them about your project?
Yeah, we're talking to some Middle Eastern actors, and it's definitely an interesting market for us. Right now, physically, it's a little far away and travel restrictions and so on. But let's see how things are next year, where we are like technology-wise, if we feel comfortable to have our robot so far away from us. And but I can very well imagine that we're just going to do a couple of projects there and going to be there for a couple of months and see how the technology works for their demands.
Does Norway not allow travel right now?
We are allowed to travel, but then if you return, you have to go in quarantine for 2 weeks. So that's kind of uncomfortable for job and work and so on.
Especially for the CEO.
Yeah, so that's something that I think actually is quite a nice side effect of this Corona thing. It's like, actually, I don't have to travel everywhere. We can take this on a video call, and business is going, and people are suddenly quite comfortable taking the things on a video call, and I suddenly have more time at home with my family and less time sitting in planes and trains and so on. That's quite nice.
Yeah, it's good to always see silver linings like that. There's definitely a more comfortable setting for Zoom calls or like Google Meets like this. I hadn't started doing these until after coronavirus, because I thought that just doing like a Skype wouldn't be worthy of like YouTube, or wouldn't be worthy of people's attention. But after I saw like big news companies like Fox, CNN, MSNBC, like all the huge companies in America putting Zoom calls on TV, I figured if they're not too good for it, then neither am I.
Yeah, I think it's a lot of people are saying in our industry that the thing in digitalization, we're trying to do this for 10 years and suddenly we made it like in 10 days because we had to, and like, hey, it works. That's quite good. And again, then from my view might be kind of biased, because I can go outside, I can more or less live my normal life. I can't travel to every customer and so on, but that's kind of okay. And I feel like for other people where I've seen in Italy or so, like people that have been sitting inside their apartment for months, it's like, then it's probably harder to see the silver lining of this.
Yeah, certainly.
How's it in Austin? How's the situation right now?
It's certainly not good. Things are starting to kind of open up. Pools are kind of open, and in public outside, people don't really wear masks, but inside, most places, people have to wear masks.
Okay.
It's nice because it's not an environment where anybody is like really yelling at you, or like I heard in LA, if you walk down the street without a mask on, someone will yell at you across the street and like yell profanities. Austin's not like that. People are very nice here. Everybody's respectful. So I think people are dealing with it pretty well, but there's definitely a noticeable rise in homelessness, and obviously like some people are out of jobs, and it's a struggle for sure. So yeah, it'll definitely be interesting to see where it leads. I guess
we were there. Yeah, I mean, we are quite lucky here in Norway because we have quite a good social system. So people get unemployment money, and there's not so many people that are falling between the cracks and have to live on the streets here. One thing that I always thought about, especially like when the crisis hit us, and we didn't know where it was going, like in March and April. It's like for us here in Norway, it meant, okay, we had to stay inside and we couldn't go to the office and stuff like that. But we had like a warm home and we had food and stuff like that. And then when I think about like my grandparents that went like through the war, and people were like starving and losing their homes and stuff like that. And then I was like, I have to be kind of grateful. Like if this is our like big test that we have to stay at home for a while and so on, then we are quite lucky compared to like what other people have to go through.
Yeah, historically, especially. And also other people like that are essential workers that don't stay home, working in hospitals, stuff like that.
Yeah, exactly.
Construction falls into essential work.
Yeah, I actually, I don't know the regulations, how they are in the different places.
It depends
here,
on construction. It depends on what's being built. Like if somebody's having a pool built in their backyard, that's not really essential work. But if it's if somebody's roof is broken and they need to have their roof repaired because it's leaking, or their electricity is not working, or something like that, or something big isn't working, or they don't have a house, then construction is essential.
Yeah, I saw it in Germany. It was quite funny when the crisis hit, and like almost all the shops had to close, unless the supermarkets and the I don't know what's it called in English, but where you can buy the construction materials, this home depots and stuff like that. And they had so huge queues because suddenly all the people were home and had like time to redo their apartments and so on. So like everybody wanted to go there and buy like construction materials, and they were deemed essential.
Yeah, I mean those things are good. It's really, I mean, people really care about their standard of living. And a lot of people talk about like inflation and different economic factors, and they're complicated factors that most people don't have a deep understanding of what pulls where. But what they really do understand and what they care about is their standard of living. And it seems to me that if you can automate tasks for jobs that people currently aren't taking and are currently understaffed for, construction labor, then you can provide a higher standard of living to more people.
Yeah, I mean, I have like a quite utopian view on this, and but for that, I mean, now we're talking about the big picture again, and there's two things. Like one is automation and like having shitty work, like doing rebar on a construction site. Like people are literally breaking their backs. Everybody gets chronic back pain that does that for a while. So before that, we used to send kids in coal mines or stuff like that, you know. Luckily, we don't have to do that anymore in our places, at least. And then, on the other hand, if we don't change the social system around it, if we just automate everything and make everything more productive, then we are going towards hell, because like all the machines are going to be owned by the 0.1%, and everybody else is just like not needed anymore. And so that could be like a dark scenario. But at the same time, I think we have all the technology to live in a quite nice place. We can have the machines do the shitty work for us, and we can do nice things with our lives. We can take care of our kids and our elderly and make art and love and I don't know what. But for that, we also need to change like some of the bigger picture of the system around it, and that's not an easy task.
Yeah, a lot of that discussion, like most people, whether they are more interested in like social politics or capitalist politics, they are coming from a good place where they want most people to be happy. And if you can get the most people comfortable in life, then that's the best scenario, wherever everyone is after that, I think.
Yeah.
And the real difference is whether you want the big power to go to the 0.1% of the people with the biggest money, or the 0.1% of the government and the people who are like in control of the whatever system is set up. And for that one difference of which 0.01% has the power drives a lot of people crazy. But
yeah, we quickly enter like a deep political discussion in there. But I think I don't know if a lot of people agree on that, but at least in my point is like the system that we have right now is kind of broken and not sustainable, and we have to change something about it so that not the focus of the system is less like having short-term profit for a few, but making life enjoyable and yeah, having a good planet that our kids can live on in the future, you know, not burn up everything. I think that's something we have to like refocus a little bit more on. That somehow has gotten out of focus for a lot of people. And that's what you said. It's like the quality of living for the people. And again, we're extremely lucky here in Norway. If you look at the rankings of the happiest people and so on, we're constantly like top 4 or something like that, because we have a shitty weather in winter, but other than that, we have a quite amazing quality of life. So that's something I'm grateful for, because that's something the people before me fixed, you know, and now I need to try to do my part so that it stays like that.
I'm a firm believer that struggle builds appreciation too. So if there's a tough winter, that brings people together and gives a sense of community.
Absolutely. You have a hard time appreciating the things before you miss them.
Very true.
Yeah. Jared, I have to go soon. I really enjoyed the conversation with you.
Yeah, it's been a pleasure.
We can maybe find some time again in the future.
Yeah, definitely. Maybe when you guys have like the next big project coming up or something, we can talk about that.
Yeah, let's see. When we redo it. Keep up the good work. I enjoy listening to your podcast and watching your videos.
You as well. I look forward to seeing the future innovations coming out of Rebartek. Good luck, man. Later on.
Bye-bye.